Hello friends, I am Radha. I am come back to my YouTube channel with new example of norm space, and here let x comma norm be a norm space and R be the set of real number, so that a mapping D such that x cross x to R defined by dxy is equal to norm of x minus y is a metric on x. Here we show that x comma norm be a norm space, and here we define a metric dxy is equal to norm of x minus y is also a metric on x. So in metric, in we prove metric space. Firstly we show four property. First, non-negative condition. Second, symmetric condition. Third, null condition. And fourth is triangular inequality. Now here I am firstly show that non-negative condition. In for non-negative condition we take two element x for all x comma y is element of a linear space x, such that this implies that x minus y is element of x, since because x is a vector space, then the difference of two element is also in a vector space. This implies that norm of x minus y is greater or equal to 0 by definition of by the definition of by definition of by definition of D, sorry, by definition of नॉर्म की कंडीशन, नॉन निगेटिव कंडीशन, नॉर्म स्पेस जो होता है नॉन निगेटिव कंडीशन सेटिस्फाई करता है, इसीलिए जो हमारा नॉर्म ऑफ एक्स माइनस वाई होगा वो ऑल्सो ग्रेटर आर इक्वल टू 0 होगा. दिस इम्प्लाइज दैट डी एक्स वाई इज ऑल्सो ग्रेटर आर इक्वल टू 0 बाई डेफिनेशन ऑफ डी, by definition of D. Now our second condition is null condition. In null condition, let x comma y is element of x such that dxy is also 0. By property of metric space, dxy is also 0 if and only if norm of x minus y is also equal to 0 by definition of D. D की definition क्या है कि dxy is equal to norm of x comma y. So here dxy is equal to 0. This if and only if x minus y is also equal to 0. If and only if x minus y is equal to 0 by null condition of norm, by null condition of norm. So x minus y is equal to 0 if and only if x is equal to y. If x is equal to y, then dxy is also equal to 0. If and only if norm of x minus y is also equal to 0, x minus y is equal to 0, if and only if x is equal to y. So here third condition is triangular inequality. In triangular inequality, we take three elements for all x comma y comma z is element of x, such that dx comma y is equal to norm of x minus y is equal to norm of x minus y plus z minus z in arrange and also less or equal to. By definition of norm is also satisfy triangular inequality, so by definition which is also less than norm of x minus z plus norm of z minus y. By definition of norm which is also a definition of dx comma z and which is also equal to dz comma y. So dx comma y which is less than dx comma z plus dz comma y. And here fourth condition is symmetric condition. Fourth condition is symmetric condition. Symmetric condition. In symmetric condition, d of x comma y is equal to d of y comma x. So now we take for all x comma y is element of x, d of x comma y is equal to norm of x minus y, which is also is equal to minus of y minus x. It is also clear about this. And by definition of norm which is also scalar quantity, then which is also a scalar quantity, then it will be minus of alpha, that is minus 1 into norm of y minus x is equal to norm of y minus x, because mod of minus 1 is also a modulus function is also a positive, gives a positive value, so it will be norm of y minus x, which is also equal to d of y comma x, which is by condition of homogeneity of norm. So from condition 1, 2, 3 and 4th, it is obvious that norm space x comma given norm is also a metric space, because it will be satisfy 4 condition: non-negative condition, null condition, triangular inequality, and 4th condition symmetric condition. In that all are 4 conditions satisfied, then the given norm which also forms a metric space under the given metric D, also a metric space under the metric D, defined as dx comma y is equal to norm of x minus y for all x comma y is element of x, and this metric D is called metric induced by norm. D is called metric induced by norm. Here some notes are given below. above metric space D on norm space also satisfying following properties like following property here dx comma y is equal to d of x minus y comma 0 and d of alpha x comma 0 is equal to mod of alpha into d of x comma 0 for all x comma y is element of capital X. Here alpha is also a scalar. In above metric space D is equal to norm of x comma y is a norm space, and due to the given metric D satisfying norm space, so it is also satisfy the condition dxy is equal to dx minus y comma 0 and d alpha x comma 0 is equal to mod of alpha into dx comma 0. And norm space is also a metric space under a certain metric D. Under a certain metric D, therefore all concept result of metric space are hold in norm space. norm space जो होता है वो मेट्रिक स्पेस भी फॉर्म करता है, इसीलिए जो सारे मेट्रिक स्पेस के जो सारे कंडीशन होंगे वो भी नॉर्म स्पेस में सेटिस्फाई करेंगे.